Hi everyone, welcome to Conic Talks webinar in November 2025. We thought we'd give you an overview and an update of what we're doing at Conic, as well as some live demonstrations of some features. So, on the assumption that many of you will probably not quite know everything there is to know about Conic, and to help you guide you through the next hour or so in terms of both presentation and demo, just a short agenda really on covering everything that's unique about Conic, our product, at live demo, and a dedicated opportunity for you to ask your questions. The QR code that you see on screen, if you're watching this live, you'll be able to scan that QR code, and at the end of the agenda you see here, we'll have a dedicated section to run through all the questions that you have asked us. If you are watching this on repeat, that may no longer be live, but of course you can ask the question in LinkedIn if that's where you're watching it, or in the video itself using the commenting features. So today you're going to hear from both myself and my colleague Jacob. Just firstly, my name is Aaron Perry. I spent the last 10 years or so working for a large architecture practice in the UK, roughly about 500 people or so, dealing with very complicated digital projects, leading their digital design group. So lots of experience working on very complex, difficult historic projects, inner city London sites. And about a year ago, I decided to go and be part of the change of building the next generation of modern BIM software. And I'm also joined by my colleague Jacob de Sutter. Jacob studied civil engineering at the University of Ghent in Belgium and has since been active in a BIM software space, first joining Brixis and then about 3 years or so ago joining the Conic team. Okay, so let's introduce you first of all to Conic as a business, for those of you who are unaware of who we are. There's actually more than 40 or so people working at Conic. It's worth me highlighting we are local to many of you. We're based in Europe and I'm based here in the UK. We are your neighbours and we want to enable you to deliver real geographical appropriate projects. We're completely self-funded, which means we don't have any venture capitalists or investors driving our roadmap. We have our users and we work with them to continue developing the product that they need. Importantly, we don't prioritize returning investor value or shareholder or dividends at the expense of developing for our users. So we're running at 100 miles an hour and building great functionality that solves real project problems. So let's talk about the product itself. Conic is a BIM modeling platform, first and foremost, but it has been developed out over 4 key principles. The first of which is no limitation on file size or complexity within your project. You should be able to open any project that you have access to in under 60 seconds. They should open almost instantaneously. You should be able to open multiple models all at the same time with no limitations whatsoever on you being able to engage with that sheer size, scale, and complexity of data. And that leads us nicely into the second principle. It's great you can open it quickly, but you should also be able to open it from anywhere. There are no limitations for specific hardware that you need to engage with your Conic projects. So you can open it from PC, from Mac, from mobile device, or straight from your favorite web browser, meaning you can access all of the information wherever you are on whatever device. No need for a supercomputer. You'll be able to open it wherever you're at. And because you can open everything really, really quickly, and you can open it from almost anywhere, the next part is that there should be no boundaries for who can engage with your projects. So with a modern, simple user interface and Conic's unlimited user licensing, meaning that everyone inside your organization can have access to Conic without additional charge, and those people you're collaborating with, you'll be able to bring them into the process without, again, having some pseudo-strange licensing agreement. Everybody that you're collaborating with will also have access to your Conic information and projects. So you can access all of your information instantaneously, you can access it from anywhere, and every single person you're working with can also be part of the process. And that takes me nicely into the fourth piece here, which is about what you might use Conic for. So to set the scene, the traditional BIM project right now might look something like this. You might have different tools and products for the different types of solutions that you're trying to solve in this different workflow. So you might have a specific tool for your modeling, a specific tool for your coordination, a specific tool for quantity takeoff, 4D planning, deliverables, 2D information, etc. And the biggest challenge with this is that often you're moving the models or you're moving data between these different solutions in order to achieve these tasks. And the biggest problem about that is that you're probably burning a lot of time and energy trying to move both the geometry and data across those different platforms without losing any information, without losing geometry, losing data, or your sanity. And probably you're losing a lot of time to do those types of things. The Qonic workflow, and probably the easiest way for me to describe what Qonic does, is it does all of those things at the same time. So you can rapidly view all your project data, you can customize design models, you can change models. With our advanced modeling kernel, you can use tools and automations to be able to enhance information from maybe models you've gained from other sources. You can enhance their level of detail, you can enhance their accuracy, you increase the amount of data within the project. You can quantify, you can simulate, you can coordinate, all in the same tool without translating, versioning, or inconsistency. So as you're modeling, as soon as you run the digital coordination process, you're looking at the exact same thing. As the model's changing, you're not wasting any time looking at a clash in your model that is no longer relevant. So to make it super clear, you're able to aggregate all the models in your project, open them instantaneously, open them from anywhere, change that geometry, enhance the detail, clash detect, resolve modeling, all in the same place, and getting highly accurate takeoff and 2D deliverables at the same time. So what does this look like to our designers? Well, for designers and a lot of our users in the design space, it is a fully flexible, fluid, custom design tool that allows you to model almost anything without the complexity or restrictions of detailed object modelers. So you're getting this idea of fresh, push-pull, fluid modeling tools, whilst at the same time having a really structured hierarchy in the background, allowing you to deliver structured BIM outputs. So again, for designers, this is the best of both worlds, allowing them to keep fluid, keep creative, but at the same time deliver complex, detailed BIM information and IFC output. For those in the construction space or building space, Conic is a fantastic way for them to be able to aggregate all the models across their supply chain, as well as their delivery team, to understand exactly what's happening in the project. Being able to open all of those models instantaneously at the same time, whether they've come from SketchUp, Rhino, Revit, or any other IFC authoring platform. Being able to aggregate those all into Conic, open them instantaneously, and engage with those models, perhaps fix or enhance some of the data that they've received in those models in order to hit that handover or deliverable, or use some of the earlier stage tools, like for example 4D planning or costing, to really understand how to bid against this job, maybe if they're trying to win the work. Again, maybe one thing to highlight here is that mobile app, allowing them to be on a construction site and see exactly the same experience that they could be having if they were sat in front of a computer back in the office. This enables people to make decisions faster and understand exactly what is or isn't in the models to be able to deliver the project. From an information management perspective, anyone with that information management function on a project also finding Conic to be extremely valuable to be able to deliver digital projects. If you can open a web browser, you can click a link and you can open Conic, meaning there are no excuses for people not to be engaged with the information management process. Finally, in owner-occupier space, Conic's proving to be extremely useful for the owner and occupier of an asset, a built asset, to be able to actually do something with the digital information that's been developed. So finally, they can open the models that they receive at the end of the project. They can spin them around in their favorite web browser or in a meeting room where they're talking about managing change in the building or looking at how they can actually manage the asset going forward. They can query, they can report, they can analyze, and of course they can look at changes to spaces and objects because it is an editing tool. This allows them to greatly reduce the cost of some of the software platforms they have access to at the moment, and also streamline from a user experience point of view, the simplicity of being able to have everybody involved in the modeling process. And I think to some extent, this is kind of unique. It allows designers, constructors, and owners to be able to talk the same language at the same time. No barriers of hardware, no barriers of software skills, just building trust in the project data and moving projects forward. So that's an overview of Conic as a business, and then also an introduction to the product itself. The best place for me to be able to continue this is with a live demonstration. So I'm just about to hand over to my colleague Jacob, who's going to walk you through every feature and function within Qonic today. Again, just to reiterate, there is a QR code on screen. So if you are watching this live, you can scan that and ask us questions. Unfortunately, if you're watching this back on repeat, you'll have to pop those questions in the comment within LinkedIn or in the media controls on the video itself. Okay, Jacob, over to you.
Thanks, Aaron. Let's jump into the product, and I'll start with a very brief high-level overview of Qonic before we jump into some more specific topics. Now, the first thing I want to show you is how we actually solved this barrier of performance that Aaron talked about. So I've opened the project here. It's a mixed-use project in the center of London, of which I have opened not only the architectural model, but also the structure, MEP, landscaping, and so on. So we have loaded in all these different models. And as you can see here on screen, I don't have any issues with performance. I don't have any frame rate drops, even though the model is quite complex and quite large in scale. So we don't want this performance to become a barrier any longer for users. We should be able to run these large and complex models with normal modern hardware without needing a supercomputer to run these models. Now, this is achieved by using modern technology like using a dynamic LOD system for streaming in detail. We're using a gaming engine as the underlying rendering method, just to keep everything really fast and performant. Now, this may be the type of performance that you may expect from a BIM viewer, but as Aaron mentioned during his presentation, Qonic is not just a viewer. It's a platform allowing you to do multiple things, such as viewing, but also things like modeling. For instance, I can take this geometry and just simply start push-pulling to modify the shape of this wall in this case. Now, in this case, this model came in as an IFC file. Could also have been a Revit file, Rhino, or SketchUp, doesn't really matter. Regardless the source of the model, we will be able to modify the model or to adapt the model to your needs. Now, because this model can come in as, for example, an IFC file, this means that we have to be able to handle geometry coming from different sources, and this also means that there may not be relations between objects in the original authoring file. So, for example, this wall here, as you just saw, I moved the thing, gave it a rotation. You can see the slab here also adapted with it. This wall here as well, even though the relation between this wall and this slab, this other wall, was not defined in the IFC file, because that's typically lost when you export from, let's say, Revit to IFC. What we do at Qonic is we actually define or redefine these relations on the fly, so you don't have to manually define these relations. But when using a tool like, for example, the Move tool, these relations are defined on the fly in an intelligent way. This helps keep the model lightweight and keeps it very intuitive for a user to start using these building elements in a natural way. All right, let's take a look at the load-bearing structure of this model. Take a look at the data of this model. So not only geometry is important, also data, of course. So let me select all the beams in this structural model. It's actually 6 structural models, so there's 6 models here, and I'm selecting the beams across 6 of these models. So here on the right-hand side, I can see the inspect panel, which basically gives me the properties and attributes of all my selected items. I have about 14,000 items selected. All of them are beams, and I can find all of their properties, materials, and so on here on the right-hand side. Now, not only can I view these properties, I can also change, adapt, modify these properties. I can remove properties that I don't need. I can add properties that are missing. So it's completely up to you how to enrich this data. For example, if I take a look at the beam common property set, which is a set that is used in the IFC schema, I can see that there's, for example, information about whether or not these beams are external, load-bearing, and so on. But maybe we want to add some more properties. So let's add a property to these 14,000 beams.
and I'll just stick to the IFC properties. So good to know is that we have actually built in the IFC data schema in Conic itself. It's at the core of our data schema, meaning that there's no import-export problem. There's no mapping of our properties with IFC properties because it's just one-on-one IFC. So for instance, let's say I want to add a fire rating and a status. Maybe I can give it a value. And I'll just save this. And now in just a few clicks, I've basically modified or added this fire rating property to these 14,000 beams across 6 different models. So you can really easily bulk modify, bulk edit geometry and data across different models in one go. Now, before I continue to the next topic, I just want to give you a bit of context. So as I mentioned, this building is located in London. And just for good measure, we've also loaded in a couple of square kilometers of London, modeled in 3D. Again, just to give you a bit of an idea of the type of performance we're able to get with Conic. So looking at London here, completely modeled in 3D. And again, no frame rate issues. Everything still runs really smoothly. And as you can see, when I zoom into objects, it's actually loading in level of detail dynamically, again, to keep everything really lightweight. All right, so let's dive a bit deeper into the product. And I'll do that by dividing the rest of the presentation into the following topics: evaluating your models, enhancing models, collaborating and coordinating models, and creating deliverables from these models. Let's start with this first one, model evaluation. So depending on what type of user you are, you might receive BIM models from a design or engineering firm, from your supply chain or subcontractors. These models might be of questionable quality depending on the BIM maturity of your partners, and they might come in different sources. Qonic allows you to import models from IFC, Rhino, Revit, or SketchUp by simply dragging and dropping a file into the dashboard. So it's just a matter of dragging and dropping a file, and once it's uploaded, you can start interacting with it. Now, let me open this model here to show you some of this evaluating models workflow. So depending on what your role is within the company, you might not have the necessary expertise, software license, or hardware required to typically interact with BIM models. We want to lift that barrier by allowing you to open the model in a browser and just start talking to it in natural language. So when I open this model here, this may be the first time I see this model, I can use the central search bar to simply start searching for objects. For example, door F60, to find all of the doors with an F60 fire rating. Looking at the properties, indeed, these are all doors, and they all have a F60 fire rating. Maybe I want to know something about the plasterboard. Maybe I want to know the net area of all this plasterboard. Should be pretty straightforward to find your way in new models. We're currently also working on a way to interact with the model with natural language. So you can simply ask questions in natural language, and this question will be interpreted by the software to help you find your way. Looks like we have a net area of 5,900 square meters of plasterboard for this model here. Now, BIM models are often kind of a black box to non-technical users. For example, when calculating quantities from a model, these numbers often appear magically without really knowing what exactly they are. So let me set this concrete slab here in scope to show you how we handle quantity calculation and how we allow the user to visualize what they're calculating. So, for example, let's say we want to know the net area of this slab here. Let me calculate the net area. Looks like it's 307 square meters. And you can see here the blue outline shows clearly how exactly this net area was calculated. So we have this rectangle with 3 holes in it. These openings were subtracted from the total gross area of this slab. If I want to know the gross area, for instance, I can also do so, and I can see that now these openings are not taken into account. Or maybe I want to ignore openings smaller than a certain size. This is customizable. You can choose, for example, the threshold area. And in this case, you'll see that this larger opening is indeed taken into account, but the smaller openings are ignored. So we always show visual feedback what exactly you are calculating. Maybe you want to know the surface area of the openings in the floor slab, which comes to almost 7 square meters based on these 12 faces in these 3 openings. Maybe I want to know the perimeter. That's 72 meters, as indicated here by this rectangle. So always we provide visual feedback how something is calculated to take away this idea of the black box of a BIM model. Now, all of our tools are designed to be user-friendly and easy to use. So for example, let's call this laser measure tool here, which is basically you drop this manipulator on your model and you'll see measurements appear. This is inspired by a laser measure tool used on site, so really easy to use, really user-friendly and intuitive. Of course, you can also get your data and quantities out of your model in a more structured way. That's what we use the report panel for, allowing you basically to customize what is shown in the report and how it is shown. So for example, here I just created a flat list of materials where I can, let's say maybe for the insulation, I want to know what the total net area is per insulation type, the net area of plaster. Maybe we want to know the volume of concrete. And again, we can always visualize exactly how things are calculated or what exactly these things are about. For instance, now the insulation materials and plaster have a color override applied. So I can very clearly see where they are exactly in the model by having this semi-transparent look for the other objects. Now, at any time, you can, of course, export this kind of report to an actual schedule. So let's export this. I'll call this material list. And I'll save this. Now, in this case, it's just a very simple flat list of materials, but you can basically use any sort of attribute or property that's in your model to group and filter. So, for example, we can also use codifications. We can import codification systems and apply these codes to objects in our model. So in this case, I have already imported the NRM codification system, which is the New Rules of Measurement, a British system, where certain measurement definitions are linked to the classification codes. This link is already automatically provided by the instance that creates, in this case, NRM. So we don't need to manually define how to measure what. So it's really easy to get standardized schedules or quantity takeoffs from your model when just applying the codes to the objects in your model. Or you can use this report panel to do visual checks for example, for property values. So for instance, let me open this schedule for doors by fire rating. So it's grouped per fire rating. And I can see that there's a couple of doors with fire rating F60, which maybe I'll colorize in, let's say, in green. There's a couple of doors with fire rating F90. And then there's also a couple of fire ratings that don't have, a couple of doors that don't have a fire rating assigned. So let's just color this red to see where they are exactly. So yeah, it looks like there's 6 doors here that simply don't have a fire rating assigned. Now, instead of having to go back to the original authoring tool to fix this missing information, I can just do it right into Conic here itself. Which brings me to my next point, which is enhancing models. So when receiving these models of maybe questionable quality from your project partners or supply chain, there may not be the time for an extensive feedback loop. Maybe some data is missing or incorrect, and you just know that if you send them an email now asking to rectify it, they'll just forget about it or ignore it because they have better things to do. Meanwhile, you still need to get your deliverables out. So instead of waiting for a revised model from your supply chain and hoping that everything will be correct, which, let's be honest, it won't, you can just fix it yourself. You can simply grab the doors and fix the fire rating yourself. All right, so that looks better. Now, what if the quality of your model is so bad that even basic information, like for example, an IFC classification, is missing? So let's show this here. I have this door, but looking at the properties of this door, I can see it's not actually a door. It looks like a door to us, but it's actually a building element proxy. Maybe the type mapping was not set up properly during export to IFC. Maybe this door was modeled in SketchUp or Rhino, which doesn't even have these concepts of IFC classes. Or maybe it was just poorly modeled by the person who created it. In any case, we can't really do much with this because it's not a door, so it's not proper BIM data. This also means that there's no relation between, in this case, the door and the wall it sits in. Meaning, if I move this door, you'll see the opening doesn't move with it, and there's no new opening created here, even though the door is actually there. So that's not really usable. So we can, of course, rectify this in Conic by simply changing its IFC class to something else. Now, I can either do this manually, so there's a full list of IFC classifications which I can choose from. But in this case, I'm actually going to let QI help me, which is our AI assistant, which will, based on the geometry and the context of this object I have selected, suggest the most likely classes, IFC classes for this door. So in this case, it's a door. This is the most likely option. So I'll just accept this. I've now reclassified this object as a door, which means if I move this door now, you will see that the opening is properly moved with it. Again, the relation between the door and the wall was not explicitly defined by us as a user, but is basically defined on the fly when you're doing this kind of operation, like moving the door. Now, let's say you're a contractor participating in a bid for a new construction, and you've received a design model from the designer. You need to create a tender offer within a couple of weeks based on this low level of development model. Now, often this model is not really usable, maybe because it was created in SketchUp or Rhino, maybe it was poorly modeled, or maybe it just was not modeled adhering to your company standards. So what we see is that a lot of contractors will basically create a new model from scratch just to be able to get this tender out as quick as possible, which is of course a lot of lost time and effort, which we want to avoid. Conic allows you to take in these low level of development models and upscale or enrich them to the level of detail needed for your quantity takeoff or during tender phase, allowing you to go from design model to construction model much faster and with more confidence. So for instance, let me take a look at this wall here. I have a wall with 3 windows in it. Looking at the properties of the wall, I can see that there's some materials assigned to it, 4 different materials, but these materials were not yet explicitly defined as individual objects or physical objects in my model. This looks like one solid single wall here. Conic allows you to split this wall into its layers. So let me do just that. I will split the wall. And basically this turns this one wall into a wall assembly, which has on the higher level still all of the properties of the original wall. So we still have a wall with properties, location, and so on. But now the wall consists of 4 building element parts, each with their own material, with their own physical object or solid, which means I can start to individually modify these objects. I can individually quantify them. So again, using this report panel, I can get some quantities of the different materials. And of course, these quantities are always up to date with the model. So if I make a change to the model, let's say I resize this window here. You will see all the quantities update here. Now, you'll notice that I resized this window without editing any parameter value. That's because this model came in from somewhere else, which means original parametrics, for example, from Revit, are lost in translation. Regardless of where the model came from, we still want you to be able to just grab it and resize it as creativity hits. It just needs to work. And in case you were wondering, it's not just a rescale along one axis. There are actual temporary constraints applied to make sure that this divider remains the same thickness and remains nicely in the middle of the window. Okay, so let's continue splitting these walls into their individual layers. So that's done now in bulk for all the walls on the 7th floor. But as you can see, some of the connections are not yet correct. So we don't want to build it like this, of course. So we could either manually fix this, or we can, again, in bulk, select all the walls and use the connect tool to automatically propose connections between these different wall layers, depending on the materials. If there's still some mistake somewhere, you can still manually intervene to make sure all of the connections are properly set. Now we can go even a bit further and start adding more materials. For example, maybe we want to add some finish layers. So let's add some gypsum plasterboard with a certain thickness. I will apply this to some rooms here. So I can just click a wall in one of the rooms, and it will automatically trace the perimeter of the room and add this plaster layer to all of the walls in this room. And as you can see, it's actually adding a physical object with a physical thickness to all of the walls. These new objects are also added to the existing wall assemblies, so they're still part of the wall. But again, I can quantify them all individually. So using this method, you can actually get a really high level of detail and get really correct and accurate quantities out of your model. Maybe we even want to go a bit further and start adding some nice shapes on our walls to add some other finishes. For example, something like this. Maybe I want to add a curve here as well. And I can use these curves again as the input for tools like the add layer command, where I can add some more material, like let's say some tiles. And this basically really allows to do a lot of automatic detailing, but where necessary, it gives you the option to really make one-offs or to really detail locally. Again, allowing you to quantify all of these individual materials, like for example these tiles, have a net area of 4.58 square meters based on this shape here. Now, let's talk about collaboration. So the construction sector is inherently a collaborative industry. So there's many different stakeholders, from designers and engineering firms to contractors, subcontractors, consultants, and of course the client themselves. Every project has a different combination of these stakeholders, making the whole thing even more complex. At Conic, we want to lower the barrier to collaboration by having one central model or set of models that can be consulted by every single stakeholder in real time, with a built-in version history so you can keep track of who changed what, when, and where, with the ability to clash and coordinate different discipline models and solve issues right there and then, closing the feedback loop to a very short time frame instead of one taking weeks. All of this in a single platform accessible from your web browser, desktop, tablet, or smartphone. Anyone can open a web browser, so there's no more excuses. Anyone can be involved in the BIM process now. Now, to demonstrate this, I'm going to simulate a two-person workflow. So I have 2 sessions of Conic open here. On the left-hand side, I'm logged in as myself, Jacob. On the right-hand side, I have the same project open, but I'm logged in as my fictitious coworker, Martin. Now, let's open the same model on both sides. And just for good measure, on the left-hand side, I've opened the desktop application. On the right-hand side, I've opened the web app, so the browser application. And as you can see in the user interface, it's the exact same. It looks the exact same, it has the exact same functionality. The only reason why we allow people to have the desktop application instead of the web browser is just to allow for more performance when it's really needed. Because of course, the web browser does have some limitations in terms of memory usage, which are not there when you're using the desktop application. But in practice, for most users, the 2 environments will be the exact same. Now, let's say we both have some work to do on this structural model. Now, before we get our work done, maybe here on the left-hand side, I want to check whether there are any issues assigned to me that I might want to take a look at before I start my other work. Let's open the issues panel. And I can see, for example, that there's an issue, columns not resting on pads. Let's take a look. Okay, so apparently there's some columns here that are not resting on these foundation pads. I wasn't really assigned, but someone tagged me in this. Please resolve this. Okay, so let's resolve this. I think we just want to move these pads up, like we have these other ones here. So I'll just select all of these pads here. And I'll just snap to the underside of this column here. Okay, so that's that. Now, maybe on the other side, I'm logged in as Martin here. I also have some work to do, and I also want to check whether there are any issues. And there's, lo and behold, indeed an issue assigned to me, or an issue where I'm tagged in. Looks like some of these pads are not, or these columns are not resting on these pads. Now, you'll notice that the change I made here on the left-hand side is not yet visible here on the right-hand side. That's because Conic works in an asynchronous way. That's something I will discuss in a bit more detail later. But basically, it's an approach based on the Git system, which is used in software engineering and has been proven to work really well. Okay, so I want to make a change here. Looks like these columns are not resting on these pads. I think the correct solution is here, replace those pads by sort of columns. So I'm just going to push-pull these columns upwards, or these pads upwards, like this. And also the bottom side. I'll make sure it aligns with the bottom of these other piles here. Okay, so that's done. Now, the actual reason why I was here logged in this model on the right-hand side was to do some other work. I actually wanted to get rid of one of these columns here. So let's say this column and this beam. I'm just going to get rid of this. And I'm going to extend this beam here to connect with this other column. All right, so my work here is done. Let me publish my changes. Now, in the meantime, here on the left-hand side, I am still logged in, so let me continue my work here. I also had some other work to do here on this model, logged in as myself, as Jacob. The reason why I had this model open was to perform a clash check between the structural model and the plumbing model. So Conic comes with a built-in clash tool, allowing you to select one or two sets and clash them against each other. So in this case, let me just very quickly, simply select the entire plumbing model, and let's do a clash check against the entire structural model. So very rough, very quick check. You can also, of course, do more advanced filters or clash subsets, but in this case, I'll just keep it simple. This is now running in the background, but I can still interact with the model. So for instance, I can already take a look here and visually see if there's any clashes. I can see indeed that there's an opening. It's not very well aligned. So maybe let's just move this opening. I'll move this opening here as well. And I'll just move it slightly so it aligns nicely with this pipe. That's already one issue solved. And in the meantime, the other issues or the other clashes have come in. So it looks like there's 173 overlapping objects between these two models. We can visualize these individually. So I can just click one, zoom to it, and it looks like indeed in this case there's a pipe segment running through a wall, like a foundation wall. I can go to the next one. So each individual clash I can visualize. Now the great thing about Conic is because Conic is not just a BIM viewer or a clash check tool, it's also an authoring platform. This means you can actually resolve this clash directly in the same environment. So I could say I want to create an opening for this pipe here. And let's introduce some clearance as well, like this. So that's already one clash solved manually. Now, what if you don't have the actual rights to actually resolve these clashes? Maybe there needs to be a change in the other model. Maybe I'm the structural engineer and I don't have the rights to modify the MEP model, for instance. So let's say this clash here, there's a pipe segment running through a couple of beams. This is a clash I cannot simply resolve by moving the beam because that would change the structural integrity of this building. So we would have to move this pipe around. Now, I cannot do this, so I'm going to create an issue and assign this to the correct person. I can add some priority. I will assign Ellie here, add a screenshot. I can add some custom labels if I want to, and I'll create an issue. And now Ellie will be notified that there's an issue, and she, having the correct access rights, will be able to modify this to solve this issue. Okay, in the meantime, my work here is done, so let me also publish my changes here, which opens up the version history panel. So as I mentioned before, the entire version history of everything that happens in Conic is stored in the cloud. So we can see here the version history of this model from the perspective of two different persons. On the left-hand side, again, logged in as myself, as Jacob. On the right-hand side, logged in as Martin. It has the exact same version history because it's the same model. You can see it's uploaded 2 years ago, and since then, different people have made different changes to this model. Except for at the top, the entire, all the way at the top, we can see the final change here is, of course, different. On the left-hand side, I solved this problem with the foundation slabs in one way, and I fixed some clashes. On the right-hand side, I removed the beam and a column. Okay, so let me publish this change. on the right-hand side. So I turned some slabs into piles and removed a column. All right? As soon as this is published, this becomes available for everyone else in the project. Now what's happening in the background is these changes that I have on the left-hand side are trying to be combined with the changes on the right-hand side. Maybe it's easier to show this visually with a bit of a diagram on how this Git approach works in Conic. So when a model gets uploaded to Conic, this model becomes available to everyone in the project or everyone who has access rights to that model. Now, as soon as someone makes a change, let's say I make a change to this model, my changes are not yet automatically visible for other people. So I can make a change, I can make some more changes. Basically what happens is a personal version of this model is created as soon as I make my first change. And I work on this personal version of the model until I choose to actively publish these changes to the main version of the model. This also means when I make changes and I'm not happy with them, I can also simply discard these changes, which means my personal version will be destroyed and we go back to the main branch of the main version of the model. Now, when you have multiple people work together on the same model, let's say we have Jürgen who makes a change to a model. Again, his own personal version of the model is created. When I make changes on this model, I will not start from Jürgen's model. I will actually start from the main public version of the model. And so a second branch is created as well. So now we actually have 3 branches. We have the main branch and then Jürgen's version and my version. We're all separate until, in this case, Jürgen decides to publish his changes back to the main branch of the model. I will still continue to work on my version of the model until I also choose to merge my changes to the main version of the model, at which point both versions will be tried to be merged or combined. This will happen in the background, this will happen automatically. You don't need to worry about this as a user, unless there is, of course, a merge conflict. So if Jürgen and I both made changes to the same objects and these changes are not possible to be combined, then you will be notified as a user there's a conflict and you'll be able to merge these conflicts manually, case by case. Now, once the conflicts have been resolved, I can continue as normal. So let's take a look at how this works in the product. So indeed, it looks like there is a merge issue here, a merge conflict on the left-hand side, because indeed we both made different changes to the same model, to the same objects. So again, as a user, I can resolve this manually. So I will click this resolve button. Looks like there's indeed some conflicts. And I will solve these conflicts by going into this special conflict resolution mode, which will highlight the different conflicts and give me the different options. So it looks like there's indeed 3 conflicts here. So for this foundation slab, for this one, and for this one. And for each of these slabs, I can now choose, okay, do I want to keep my version or their version? So my version on the left-hand side, which is just moving these slabs upwards. Oh, there we go. Or their version, which is turning the slab into this sort of pile. Now in this case, I just want to keep my changes. So for all 3 conflicts, I will just keep my own change here. Which means moving all 3 of those slabs up. As soon as they're all solved, I can continue as normal and the conflicts are resolved. So going back to my version history, I will now be able to publish these changes. There's no longer a merge conflict and I can continue as normal. Because we have this version history, we can always track who has done what at what time. It's also possible to always export any version of the model to IFC. So either the latest version or a version of 8 months ago, doesn't matter, every version can be exported to IFC. And it's also possible to compare 2 versions, any 2 versions of the same model. So, for example, the last 2 versions can be compared. or you can compare the latest version with the one of 8 months ago. And this basically, again, opens Conic in a special compare mode, showing you visually the different changes that have been made, as well as their impact on your quantities and so on. Now let's talk about a final piece, which is deliverables, creating deliverables from your model. So I just talked about the first one, which is of course creating IFC files from your model. So at any time you can generate IFC files from your models. It's just a matter of choosing your version, let's say this final version here, clicking export, it'll prepare a link, and within a few seconds I'll be able to download this IFC file to my machine. Another form of the deliverables is things like reports or schedules. So I showed you before that we can create reports, takeoffs, and so on from our models within the model environment. For example, for the smaller building here, we created this material list. I exported this material list to my dashboard, which means it's now available in my reports section here in the project. So a half an hour ago, I created this material list, and I can now consult it here, which shows me the exact same values, the same results as I saw before during my in the model environment. At any given time, I can export this to CSV, or I can open this link, which basically opens the model with these objects highlighted, so I can always know at any given time what exactly this quantity of 4,300 square meters refers to. And then there's a final type of deliverable, which I have not talked about at all yet, which may be a bit of the elephant in the room for some people here, which is 2D deliverables, 2D drawings. Now, this is something that I am not able to show you just yet, because it's currently still in the works. I just want to say that we have some really exciting stuff going on there. So keep an eye out for further updates if you want to see this in action. Okay, I think that's pretty much the live demo part of it. So Aaron, back to you.